NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will build an intuitive understanding of the cologarithm, define it clearly, derive the step-by-step algorithm for computing it from a logarithm, and finish with quick numerical examples. Start with the definition. The cologarithm of n, base a, is the logarithm of 1 over n, using the quotient rule that equals the negative of the logarithm of n. Two very useful identities follow immediately. The cologarithm equals the logarithm of the reciprocal, and you may also view it as a change of base to the reciprocal base. Now, let's derive the practical algorithm you often see in logarithm tables. We write the logarithm as a characteristic plus a mantissa. Suppose log base I of n equals n dot p, where n is the characteristic and p is the mantissa. By the definition, the cologarithm is negative log, so negative n dot p. Split it as negative n minus 0 dot p. To keep a positive mantissa, subtract and add 1, negative n minus 1 plus 1 minus 0 dot p. Group the characteristic and convert the mantissa 1 minus 0 dot p, which we call 0 dot p prime. The final bar notation is overline of n plus 1 dot p prime. Rule summary: add 1 to the characteristic and make it barred. Replace the mantissa p by 1 minus p. This guarantees a positive mantissa in the bar notation. Let's practice with quick examples. Example: if log base 10 of n equals 2.4783, find its cologarithm in bar notation. Add 1 to the characteristic to get 3 barred, and complement the mantissa. 1 minus 0.4783 equals 0.5217. So the cologarithm is bar 3.5217. Another quick check with a familiar number. Common logarithm of 0.005 is bar 3.69897 approximately. Its cologarithm is the negative of that. Bar 3 becomes plus 2, and 1 minus 0.69897 equals 0.30103. So the cologarithm is 2.30103, which equals the common log of 200. To summarize, cologarithm is a compact way to write a negative logarithm while keeping a positive mantissa. Use the two-step algorithm. Increase the characteristic by 1 and bar it, and complement the mantissa to 1. Practice a few by yourself to make the process automatic. Welcome! In this short lesson, we will learn the concept of the cologarithm and solve 3 quick examples exactly in the order shown on screen. The key idea is colog of x equals negative log of x. Example: we begin with the first conversion. If colog of x equals 12.5678, what is log of x? We'll show the steps one by one. Step 1. Use the definition. Log of x equals negative colog of x. Substituting the given value, we get log of x equals negative 12.5678. Step 2. Convert the negative common logarithm to bar notation. A negative log with value minus 12.5678 equals minus 13 plus 1 minus 0.5678. The mantissa becomes 0.4322, so the final bar notation is bar 13.4322. Now the second conversion. If log of x equals 7.5836, what is colog of x? Apply the definition again. Colog of x equals negative log of x, so it is minus 7.5836. We convert this to bar notation by taking minus 8 plus 1 minus 0.5836. The mantissa is 0.4164, giving bar 8.4164. Lastly, the third conversion. If log of n is bar 2.21450, what is colog of n? A bar over 2 means the characteristic is negative 2 while the mantissa stays positive. So log of n equals negative 2 plus 0.21450. Colog n is the negative of that entire quantity, 2 minus 0.21450, which equals 1.78550. Recap. The single rule to remember is colog equals negative log. Using that rule, we obtained 1. Log x equals bar 13.4322. 2. Colog x equals bar 8.4164. And 3. Colog n equals 1.78550. Practice by creating your own numbers and converting between negative decimals and the bar notation. In this example, we will use the definition of the cologarithm and the power rule to compute log of the square root of x, given colog x equals 2.8122. Here is the given information highlighted. Step 1. Use the definition of the cologarithm. By definition, colog x equals negative log x. Therefore, log x equals negative colog x. Substituting the value 2.8122, we get log x equals negative 2.8122. It will be useful to remember that a common logarithm can be written as a characteristic plus a mantissa, where the mantissa is between 0 and 1. Step 2. Apply the power rule for logarithms. Log of a to the b equals b times log a. Therefore, log of square root of x equals 1/2 log x. Step 3. Substitute the value for log x that we already found. That gives 1/2 times negative 2.8122. Step 4. Multiply by 1/2. We obtain negative 1.4061. Step 5. Write this as characteristic plus mantissa. Negative 1.4061 equals negative 1 minus 0.4061. Step 6. The mantissa is required to be between 0 and 1. So we adjust by subtracting 1 and adding 1. That is negative 1 minus 1 plus 1 minus 0.4061. Step 7. Combine the integers and the fractional part. Negative 1 minus 1 equals negative 2, and 1 minus 0.4061 equals 0.5939. Therefore, log of the square root of x equals negative 2 plus 0.5939. As a quick recap, the result is written in standard form with characteristic negative 2 and mantissa 0.5939, which lies between 0 and 1. Final answer stated clearly. Log of the square root of x equals negative 2 plus 0.5939. In summary, we used 3 ideas: the definition of the cologarithm, the power rule, and the characteristic plus mantissa convention to keep the mantissa positive. In this example, we will compute the cologarithm of the square root of x, given that log of x equals 2.26. We will also express the final answer using characteristic and mantissa with a bar over the characteristic. Step 1. By definition, the cologarithm of any positive number I is the negative of the common logarithm of a. So colog of square root of x equals negative log of square root of x. Step 2. Use the power rule for logarithms. The square root of x is x to the 1/2, so negative log of square root of x becomes negative 1/2 times log of x. Step 3. Substitute the given value. Log of x is 2.26. Half of 2.26 with a negative sign gives negative 1.13. Recall, in characteristic and mantissa form, the mantissa must be a positive decimal between 0 and 1. When a logarithm is negative, we keep the mantissa positive. When a logarithm is negative, we keep the mantissa positive by borrowing 1 from the integer part and writing a bar over the new negative characteristic. Step 4. Separate the integer and the decimal parts. Negative 1.13 equals negative 1 minus 0.13. Step 5. Make the mantissa positive by adding and subtracting 1. So we write negative 1 minus 1 plus 1 minus 0.13. That equals negative 2 plus 0.87. Here is a quick number line picture. The point negative 1.13 is the same location as negative 2 plus 0.87. The jump of 0.87 to the right keeps the mantissa positive. Step 6. Write the result with a bar over the characteristic. Negative 2 plus 0.87 is written as bar 2.87. Example. We will solve a classic cologarithm question step by step. If colog of x equals 13.5217, between which powers of 10 does the fifth root of x lie? Step 1. Recall the definition of the cologarithm. Colog of x equals negative log base 10 of x. So if colog x equals 13.5217, then log x equals negative 13.5217. Using bar notation for the negative characteristic, that's log x equals bar 14.4783. Step 2. The mantissa is between 0 and 1, so with a characteristic of negative 14, we have 10 to the power negative 14, less than x less than 10 to the power negative 13. 10 to the negative 14 is less than x is less than 10 to the negative 13. Therefore, 10 to the negative 15 is less than x is less than 10 to the negative 10. Taking fifth roots gives the fifth root of 10 to the negative 15, less than the fifth root of x, less than the fifth root of 10 to the negative 10. Finally, that simplifies to 10 to the negative 3, less than the fifth root of x, less than 10 to the negative 2. Therefore, the fifth root of x lies strictly between 10 to the negative 3 and 10 to the negative 2. Example. We will find how many zeros appear before the first non-zero digit after the decimal point in the number open parenthesis 1 over 4 close parenthesis to the power 10, given that log base 10 of 2 equals 0.30103. We will carefully follow each algebraic step, exactly in the order shown in the reference solution. Step 1. Rewrite 1/4 using exponents of 2. First, 1/4 equals 4 to the power negative 1. Since 4 equals 2 squared, we obtain 2 to the power negative 2, all raised to the 10th power. Step 2. Use the power of a power rule to multiply the exponents and obtain 2 to the power negative 20. Step 3. Take common logarithms of both sides. Step 4. Apply the power rule for logarithms. The exponent negative 20 moves to the front as a multiplier. Step 5. Factor the minus sign as 20 times negative log 2. Step 6. Introduce the Cologarithm. By definition, co-log of a equals negative log of a. Therefore, negative log 2 equals co-log 2. Step 7. Using the given value log 2 equals 0.30103, we compute co-log 2 as 1 minus log 2, which equals 0.69897. In table notation for negative logarithms, we write bar 1.69897, which means negative 1 plus 0.69897. Step 8. Distribute the 20 to get negative 20 plus 13.9794. Step 9. Add the terms. The value equals negative 6.0206. In characteristic, mantissa form, we write bar 7.9794, which means negative 7 plus 0.9794. Final step. For a number between 0 and 1, a logarithm with characteristic bar, C indicates there are C minus 1 zeros after the decimal point before the first non-zero digit. Here C equals 7, so there are 6 zeros after the decimal. If we include the single zero before the decimal point, there are 7 zeros in total. Let's also show the decimal approximation to confirm. Answer: 6 zeros after the decimal point, and 7 zeros if the decimal zero is counted. Example. We will find the number of digits in the number open parenthesis 6, 25 close parenthesis to the power 10, given that log base 10 of 2 equals 0.30103. Step 1. Rewrite the base in terms of 5. Since 625 equals 5 to the 4th, we have open parenthesis 6, 25 close parenthesis to the 10 equals open parenthesis 5 to the 4th close parenthesis to the 10, which is 5 to the 40. Step 2. Take common logarithm of both sides and use the power rule. First, log of open parenthesis 6, 25 close parenthesis to the 10 equals log of 5 to the 40. Then the exponent comes down. Log of open parenthesis 6, 25 close parenthesis to the 10 equals 40 times log 5. Step 3. Express log 5 in terms of log 2. Since 5 equals 10 over 2, log 5 equals log 10 minus log 2, which is 1 minus log 2. Step 4. Substitute the given value of log 2 equals 0.30103 and compute. Step 5. Interpreting the logarithm. The integer part, called the characteristic, is 27, and the decimal part is the mantissa. The number of digits of a positive integer, n equals floor of log base 10 of n plus 1. Since the characteristic is 27, the number of digits equals 27 plus 1, which is 28. Since the characteristic is 27, the number of digits equals 27 plus 1, which is 28. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.